So how to write a custom data type? So to write a custom data type, what we need to do, we need to implement the writable or writable comparable based on what is your requirement. Let's say I'm going to write a data type for a key. I'm going to write a data type for a key. That time you need to go with a writable comparable. What this writable comparable will do, the writable not only doing a serialization or deserialization, it will also compare the, you will write your comparison logic here to compare the whether the two words are I mean if it is a word or if it is some other value, so whether they are equal or not, whether while going through sorting phase, which one has to compare, I mean which one has to come first, which one has to come next. So that will be done by using compare to. Okay, suppose if you are taking your custom data type as a key, your mapper output to key, it means I mean K2, so we should go with the writable comparable. Let me show you here something. Let's say you are writing a custom, so K1V1 anyway it is based on the K1V1 is based on the data type or input format you are taking, based on the input format, based on the input format. The K2 V2 what we will be having control, correct? So this also we can modify, but when you go with the custom data type, when you go with the custom data type, I can tell you what is the K1V1. We can also write our custom data type over there. But in a K2 V2, let's say your V2 is a different data type. Let's say your K2 is a, not V2, sorry, your K2 is a custom data type. Let's say here diagram. Let's say here diagram, or let's say it is my own data type. Let's say my own data type, the composite data type, composite key. So this case, what we need to do, we have to go with the writable comparable. Writable comparable. Why writable comparable? Because this key 2 or K2, we know that it will go through short and shuffle phase, right? Right, Madhu? This K2 will go through short and shuffle phase. So while it going to short and shuffle phase, you are going to write your own custom data type. Your Mapreduce framework will not understand how to do a comparison between two keys. So you have to provide that comparison logic by using this comparable interface. Look at here, by using the compare to method, by using comparable interfaces. Actually, it's comparable interface. We have to provide the logic for compare to method. Understand how to compare. Suppose you are going to write a custom data type for V2, custom data type for V2, you can go with the writable only, because the values anyway they are not comparable. They are not going to sort force any phase, and they are not going to V2, the values will not be sort, or will not, no need to compare the two values, three values, I mean the values. Okay, that's why. So when you go with a custom data type, if it is a K2, we should go with the composite key, I mean a writable comparable. If you're going through value, you know, you can go with the simply writable. Is this clear, Madhu?
Yep. That's clear.
Right, this is clear, right? We had a discussion about this from long back. And let's see now the new requirement. Now, as of now, what we have seen only one reducer. We have seen only one reducer. Now let's say I have a multiple reducers in my system. I have a multiple reducers. Let's say here, let's say, let me close all the programs. Let's see. In this word count program, what I'm doing, instead of a single reducer, instead of going through a default reducer, I'm specifying here I need two reducers. What I am doing here, I need two reducers. It means, so my output should go to two reducers. How it will work? When I go with the multiple reducers, how it will work? When I go with the multiple reducers, how it will work? Let's look at here. I'll explain that. So when I have a multiple reducers, like let's see, you guys know it. Let me write a mapper. It's a mapper 1. Sulba, are you able to hear us?
Yes, Veera.
Mapper 2. I have a mapper 3. There are three mappers. Mapper 1, mapper 2, mapper 3. There are three mappers. Okay. And this mapper is giving some output. And this mapper is giving some output. And this mapper is giving some output. Correct? Then this output will go through shuffle and sort. Correct? It will go through shuffle and sort. Then let's say before it was only one reducer, the whole data will go to only one reducer. Let's say I have multiple reducers here, R1, R2. Now my question is after the sort and shuffle, how it will decide which reducer has to get which key value pair? How it will decide which reducer has to get which key value pair? Let's say I'll be having so many word count, right? Let's say this word count. So which are the words has to go to this reducer? Which are the words has to go to this reducer? Who will decide that? Who will decide that? So there is something called partitioner. There is something called partitioner. What is that? Partitioner. That guy will partition. This guy will do partitioning. What partitioning will do? This guy will decide based on the partition logic which key, which word, I mean which key value actually, so which k2 v2, which k2 v2 has to go to this guy, which k2 v2 has to go to this guy will be decided by partitioner. uh, Listen guys, this is another concept which is called partitioner. The partitioner used to decide which key value pair has to go to which reducer, right? So there is something called default 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 partitioner. Default partitioner. What is default partitioner? Who is that? So there is something, a class hash partitioner extends extends partition, and this guy will have, there is something called get partition. Get partition. This guy will take K2 comma V2 number of reducers. This guy will take K2 V2 number of reducers. So in this, what he will do, he will return K2 K2 dot hash code modulo by number of reducers. Number of reducers. So very simple logic. It is a hash code based. To tell you in a very simple way, this is hash code based. What he will do, he will take the K2. K2 is nothing but a word, right? A key. K2 mapper output key. So it will find that keys hash code and modulo by number of reducers. Number of reducers. Now let's take a simple example. We are doing with the we are dealing with the word count, right? We are dealing with the word count. Let's say the word is HD Hadoop and other word is HDFS. So who has to go to which key value pair? Okay. Now let's assume that this this guy's hash code is 100. This guy's hash code is 105. Okay. Now this is K2, right? So K2 dot hash code. So 100. 100 modulo number of reduces. So 2 reduces. So what will be the remainder? What is the remainder?
Zero.
Sorry?
Zero.
0. It means the first reducer. It means it has to go to Hadoop has to go to reducer 1. And next 105. 105 modulo 2. A remainder is 1. So it means your HDFS has to go to reducer 2. Understand guys? Understand? Yes or no? This is called
Yes.
hash code partitioner or hash partitioner. The default partitioner in the Mapreduce is hash partitioner. Based on the hash code, he will decide which key value pair has to go to which reducer. He will decide. Suppose you don't like to go with a hash code partitioner, you want to write your own partitioner, that is called custom partitioner. What you can do, you can simply write your own partition logic. Word count partitioner, extending partitioner, you have to provide your own logic here. You have to provide your own logic here. So what is this logic? I'll explain. So here you need to provide what your own logic. Okay, let me show you another scenario. Let me show you another scenario. So I have a list of employees data, and in that I have something called male, female, and some other gender. Male, female, some other gender. So what is some other gender? It's like it is let's say sometime we're missing data while entering into gender field. Sometimes we are giving us special characters there, or it's a third gender. Okay, so in this now all males has to go one file, all female has to go another file, all other third gender has to go into different file. Now what I have to do? What is my logic? So my output should be all male employees in one output file, all female employees in other input file, all third gender should be in other output file. In this case, what I will do, I will write my custom logic. Guys, look at here. How will I write? Class gender partition extends partition. In this, what I will do? Get partition method. So public int get partition, who will take k2. K2 is nothing but a key. V2 number of reduces. So inside the get partition, if mail dot to lower dot equals k2. If mail dot lowercase, because I'm converting everything, so I don't want different case. So mail dot to lower dot equals of k2, then you return 1. Else if female dot to lower dot equals of k2, return 0. Else return 2. So now you guys understand here what happening. So if it is a male, I'm passing 1. If it is a female, I'm passing 0. If it is a else other case, I'm passing 2. So what will happen here? All males will go to reducer 2. All females will go to reducer 1, as we discussed before. All males has to one the reducer 1, and all males has to be in reducer 2, and all other genders will go to reducer 3. Now 3 output files will be generated based on your based on your based on your data. Clear? Sulba, Srikanth,
Yeah.
Sulba.
Yes, Veera.
This is called partitioning. This is called partitioning. Let's look at guys here. So let me show you the source code of the hash partition. You will get some idea about it. So Control Shift T. Yep, very good. Look at here. So as I explained before, there is something called default partitioner, which is a hash partitioner implements. So here it is showing implements, but actually it is extends. So I hope it's a old API. It's talking about old API. So it's showing implements. Actually it is abstract classes there. So we have some abstract classes there. Abstract class and get partitions, your k2, v2, number of reduced tasks, your key dot hash code modulo by number of reduced tasks. Not to worry about the maximum value of integer. So they're just doing a binary operation here, bitwise operator. So you don't worry about it. So your default partitioner is hash code partitioner. That hash code partitioner will take the hash code of the key. Key is nothing but your k2. It will take that key and modulo by number of reduced tasks. Then it will find the hash code, and based on it will do the modulo, and it will find the which reducer has to execute. Suppose if you want to write your custom partitioner, you will write your class extending by partitioner. As I said, is a partitioner class is the your abstract class. So here it is, actually it is not able to load. So if you're using extends, you can easily understand it is abstract class. Look at here, subtract method, and let me show you it is abstract class, partitioner abstract class. Okay, so it has a get abstract method, sorry, get partition method, and get partitions will do nothing. It will take the k2 v2 and find the, so you have to find it. So it take the string, convert into case, and you can check the values and all. I'll explain you what I'm doing here. So it's pretty simple. I'll tell you that. First, I want to know whether you understood or not about the partitioner. Do you guys understood or not about the partitioner?
Yes, sir.
You guys understood, right? Yeah.
Mm-hmm.
So let me show you something. So when you run this partition logic in your local, right, you may not able to understand this. When you run this in the local mode, when you run in the local mode, so you're telling that, let's go here, Java application. Array index out of bound exception. So I understand why it is. Right click, run as, run configuration, go to driver count, take the arguments are there. Okay, so just finish the run method. Now it looks good. Before it actually, it is created a new thing, and there we didn't pass the parameters. It's running. Here also it is giving some out error. Input path does not exist. So desktop sample.txt. Maybe I have removed it. So desktop, there is no sample.txt because I have moved to here. I have moved to, yeah, here I have sample.txt. So input data. So I need to give a proper path. It's a path issue, so nothing to worry. So it's a path issue. Just go here, run as, run configuration, arguments. Here instead of this, because I have moved into input data. Input data. There is something called I have moved to input data. So that's why input data. So it is showing error. So if you apply the logic here, apply, just run. So here I have set a 27 reduces. 27 reduces. I have written my own logic here. I have written my own logic. So what is to be done? It has to create a 27 output files. Yes or no? Let's look at how many output files are created. Oh, it is only one output file because it is a local mode. It cannot understand how many slots, how many has to launch and all. It will not understand because it is a local mode. Local mode means it's nothing but a Java application, a plain Java application. So here I didn't write a multi-threaded program. So to process multiple ways. So it's a plain Java application. That's why you are seeing only one output file. If I do same, see here I have written my custom data type. Here I have written my custom partitioner, not data type, my custom partitioner, and I have given 27 reduces. What does it mean? Now this code should act as a multiple reduces, right? So what is the use case here I have followed? The use case is the same use case. The use case is I want if any word start with let's look at here. Let me open the input. First let me open the input. Suppose if any word start with A, if any word start with A, that word has to go to file 1. If any word start with B, that data should that output has to go to file 2. If any word start with C, that word should go to different file. If any word start with D, that we should go to another output file, like that and so on. If I have anything special characters, the special characters should go to a different output file. That is a use case. The problem statement is very simple, guys. The problem statement is if any word start with A, that should go to one output file. If any word start with B, if any word start with B, that output should go to other file. If any word start with C, that output should go to other output file and so on. Okay, that is the use case. For that, to solve that problem, what I need to do, I have to write partitioner. I have to write partitioner because I have a multiple reducers. I have multiple reducers. How can I achieve that? So if you look at here, what I have done is pretty simple, guys. Pretty simple. Nothing great here. So what I have done here, I have taken this the key is which is text type. I need to convert into string. I have converted here. After converting it, I'm taking the first letter because I need the first letter only, no, to check whether it is A, B, C. I need to check the first character. So character at of 0th position, and I'm doing minus A. What is this? Actually, I'm trying to find the ASCII. ASCII. What is ASCII? American Standard Code Information Interchange. ASCII. ASCII of the first character of each word and find the modulo by number of reducers. And I'm taking the tie. I'm taking the tie. And if the tie is greater than 0 and less than 26, then return the tie. Because my reducers will start from 0, no? 0th reducer, first reducer, second reducer. So I may get the value, if I get the value in between 26, return the tie. If it is more than that, you can return something else. So why I have taken 26 here? Because all the special characters, all the special character has to go 27th reducer. 27th reducer. If it is a 27th reducer, because my reducer start with a 0, 0 to 25 is alphabetic letters. 26th one is special characters, special character. That's why I have written this logic. You guys execute this logic, it will work and it will also create 26 reduces. Because I have already executed, I'm just going to show you an output of this. Um, oh, it's not there, it seems. Yeah, multi-reduces output. Look at, guys, here. How many part files? 0, from 0 to 26. 0 to 26 means 25 reduces. You may see here some of the reduces are 0 bytes. Some of the reduces are 0 byte. It means there may be a data for that. There may not be a data. Actually, there is no data for those reduces. There is no data for those reduces. Understand, guys? Any doubt? Masudan, Srikant, Sulba?
No, 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 it's clear.
It's clear, right? So please execute the program. The code is already there in the drive. Please try with it. The code is already there in the drive. Please download and please try to execute it. Programs, this one, hands-on 5 to 6. And this you have a SRC. In this you have a COM. In this you have a Vira, MR jobs. There is something called MR jobs. Yeah, MR. In this jobs, if you see here, partition. Okay, so what needs to be remember here, the once you write your custom partitioner in the job, you have to set it. You have to set it in the job. You have to set it. If you didn't set it, your framework will not to come to know how to set number of reduced tasks. And also you need to set partition class. You have to set by using set partition class, using set partitioner class. If you didn't do these two, it will not work. If you didn't do this, what will happen? It will execute default one. If you use this, it will use your own partitioner class. Clear? Yeah, so that's it for today. So tomorrow we will continue with a new topic. Clear, guys? Sulba?
Yep.
Yep. Thank you, guys. Thanks for your time. Have a great day. Okay. So guys who join now, please wait. I'll just back in 2 minutes, okay? Because the recorded video has to